In previous lesson, we learned about the key concepts of STL, Standard Template Library. Now we'll dive into the advanced concept of STL, and you will generate code with our prompt. And our prompt says advanced STL user instruction, and we are asking custom comparators that we want and using comparator functions or functors. Then lambda function, we want that to use in these, use lambda expression in STL algorithms and sort for each and find if, etc. And then create a mini project, a leaderboard system. Create a small console app that mimics a simple leaderboard using vector or map. We are giving an option, and then we're asking, okay, print the with cout statements, add cout statements to display the values. And our goal is to learn, having a hands-on experience, practical, give learners practical hands-on experience with custom sorting function style. This is the advanced concept. So if someone doesn't know C++ and STL, this will be hard. So I will definitely will suggest to go back and learn the foundation concepts, previous lessons from C++ course or C. That will help. Now we are asking the code generator, the code copilot, to generate code for us. Enter. And it is working. Let's see what it does. We have, in a few seconds, it's a pretty good chunk of work. And we still have a mini project requested. So let's see it started. That's so quick. And it is doing some student class struct. So and we are demonstrating custom comparators for vectors using vector, and then we have lambda function. Lambda function is you can have on the fly, write a function, use it on vector itself. And we are using countif and for each. For each for the vector, and there's a mini project leaderboard. Let's see what it does. Leaderboard class, update score, there's a vector, and there is main. So we have the code ready to roll. Custom comparator, standalone comparison function for sorting by different criteria. These are the highlights of this program. Custom comparator, lambda function, basic lambda function, and they are used with STL algorithms that we asked for, capture variables, explicit return using lambda for filtering, transforming, and aggregating data. And the leaderboard has practical examples with player class, and the leaderboard has methods such as adding, updating the players' information, and getting top players. The leaderboard always like that, it will stay in that order. Filtering by score, threshold, filtering by game type, custom filtering with lambdas, and so on. Formatting display, readable data. So we have the code, and let's take the code to our editor, just like we did earlier. So here is the apply to editor. File name is advanced STL, advanced STL.cpp, and we enter that. Now we have advanced STL, not there is another advanced STL, and there it is, advanced STL CPP. So we have in the editor, and we hide the chat window, and let's go through the output and the code. First, let's compile it, and then we'll create output. We have our file, advanced STL. Let's compile using C++, advanced STL, STL, spelling, output, advanced STL. Oh, not CPP without extension. Oh, there is some compilation error. What's there? Maybe, oh, there is an error. So we have no matching constructor for initialization of player. Line number 165. So we have a problem with the player class, and player class needs a default constructor, and we just ask the Copilot itself to fix this issue, and I asked this, giving the error, fix the error, this one. So it generated the code with the default constructor. So that's what it figured. It's likely happening because STL algorithm or container are trying to default construct a player object at some point. Actually, it is done here. Is a container is created using this or somewhere. I think we need a default constructor. So let's do this and update our file, and so it's just the difference is default constructor. Yeah, that's the default constructor added here, and we then will compile and see what it does. Keep it. So we then save, already saved, and we compile again, and it compiled. That's what is needed for this. And we hide the chat window again. So it compiled. Sometime we have to ask the Copilot to fix it, or sometime we do manually. We notice already, I noticed before asking the Copilot to fix it, and it just did that. It added a default constructor. Earlier it was not there. Sometime the code generation fails to catch those nuances. And we have this, and we have the output, advanced STL, and we have that. And if we run, we get the result. Let's see what we have. Okay. We have the code and the result. And first thing first, we see the main custom comparator is using. So we have a vector and original list is printed here. The vector student with the name and some numbers. And that is there, score, for ID and the score. And that's there. And sorted by name, a student sorted by name, and compare by name. Here is the functor. This is a function. This is not a functor, and it should be in the top here. It's a function, a student, and so if the name is A, first one less than B, name, in the ascending order, then it will return true. And so that's where it is, this function will do. In a sort function, it will go by each element and it will use this function and then compare less than the one element is less than the second one, then if not, they will be sorted. And that's by name, and then by score. And this is by name, and this is by score, and score like this in descending order. Score, compare by score, and it has, yeah, A is greater than B, so descending order. And then we have sorted by score, ascending order with functor. And this time it's a functor. This is a class score comparator, and if it is it's taking a true score by ascending order functor. Okay, and this is a class, and this has a operator like this. That's your constructor. This is a constructor. It's taking as true ascending. This is the operator, overloaded operator, like this function call operator overloaded using the student A and student B. That will be called, and that ascending is a boolean. It's set here. Initialize with true. Also, we send a true value. If they are ascending, return ascending is true, then you go like A score is less than B score. First one is less than second one. If it is descending, it will go otherwise. So we can look at the caller here. We send true, and this itself will call that function and sending each item from this, from beginning to end. No, not each item, two items to compare. So that is functor. And we see that descending order, and this is ascending order. Okay, and using comparator with std set. This is a descending order using custom comparator with set. So we have a set of students using that same functor. We can use it. We can sort it. automatically keep the student sorted by score in this score comparator. And student set, insert the same students. So whenever we are inserting, this comparator will be used and automatically inserted in the order. And print the set will be in order of score. And let's see the set order of score. And yeah, this is in descending order. This is false, that's why. Okay, descending order. And 92, 88, 85, 79, and 78. These are descending order. All good there. And some key points for the custom comparator is we have used functions and function and the functor. Functor is a class which is which has a overloaded function of the function call, or two parentheses, and using that the comparison is made. Okay, key points are enable sorting by any criteria or in any order that we did, ascending, descending order based on that, and can be used with many STL algorithms, sort, max element, and so on. That functor can be used, and also different data types, set, data structures, I mean, set, map, and like that, different containers. And function object, that is functor, allow configurable comparison logic. Yeah, so it has like true or false if it's ascending or descending, and you can configure any way that you want. And lambda function next. Lambda function is is a lightweight function on the fly. It has no other place that in definition it will be in that. Here it is print vector is a lambda function. This definition is like this. It takes parameters, many, and then it also returns after doing the function. Again, it goes lambda, it's a function, and it will do the thing that we want to do. So print vector is called here, and this is the label and the numbers. Numbers got printed. Numbers got printed. Original is this. Using the lambda, it is this. Okay. Original is this, and the lambda is this. Sorted. Descending order. And it can be used in the for each, and it is here it is assigned to a name called print vector. However, we can just have it there like this. In the for each, so what it says, double the value not using reference to modify. Here, it is this lambda takes a reference number which will be sent by for each function from beginning to end, and that will be doubled. So these values are doubled here. Here, this original, that's the one. Okay, that's there. After doubling, you print that doubled, and find if also you can have a lambda function right there if number is greater than 6, and then you return. And here in this case 8 is greater than 6 of the original vector, so position is 2. Lambda with capture clause. Lambda with capture clause. Oh, here is what it displayed by calling this find if number for each number it and it not equal to number. First number is 6 at position this. First number greater than 6 is at this position. So this iterator is returned for the 8 because that's the first one greater than 6. And next, lambda with capture clause. Okay, here, lambda and count number of uh, elements, count elements above threshold, capturing the threshold variable by value. And that's what it did. It's lambda function. Count the numbers, threshold, count the numbers greater than the threshold here, greater than 5. So it will return the count as soon as as the number given threshold 5 and greater than there are how many? 4 numbers more than 5. Yeah, 8, 9, 7, and 6. Okay, that is there, and you can have a range like this. This is a lambda function, and you can define like this or assign the lambda function into a variable like function, and this works like a function pointer, and you pass here a function pointer, and then it will do the work. So lambda with mature capture, sum of all element, you can have that, sum going through for each. This is a lambda function here, and lambda with explicit return type, and lambda that returns true if a number is a prime. This is the prime number checking, so we are not going to the detail of the math. I just know that if it is when it is found, it will return true. If not, return false is prime. So in the for loop here, prime numbers in the list that is displayed here. Where prime numbers? Yeah, these are the prime numbers. Complex operation with lambda. Then in the for loop, even sum. Okay, this is a little bit complex, finding the mode of the number. If it is 0, then it is an even number, and adding to that becomes sum, and all sum of even number is 20 here. And the key points are, it's a compact inline function definition. We know the inline function in C++ concept, so which is you can have a definition and then you call that definition as an inline. In this case, it's an inline function and compact at the place where we are calling. Perfect for one-off operation with the STL algorithms and can capture variables from surrounding scope. Okay, yeah, so we saw that the variables are passed to the lambda function. Make code more readable by keeping logic close to each other, close to use, where it is used. It's not, there is no separate definition. We saw that within that scope here, right here, within the for each, within the for loop, and so on. And avoid creating named function for the simple operation. If you have a function name and it defined somewhere else, and if we call, there is an overhead of the function call to the stack of the call stack, and then return, and there is overhead that is avoided here. Okay, now we have the leaderboard. Player is a class, and leaderboard is a class where players are in the leaderboard as a vector. And this class contains name, score, and the game. Name, score, and the game. So we have add players in this vector, and then return all players, and then get top players functions. Get players above the score if we want. It will go through that sort and then find, copy if. We saw those functions earlier. And get player by game. So we have name of the player, score, and the game, and then display leaderboard. And in the display is using a formatted pattern where it displays the value and with a width, set width to 20. For example, this is the here, this is the one display player score, rank, player score, and game. This is the one header. And then there are values, name, score, game here, rank. So it did from the list, from the leaderboard, in that order it printed. And leaderboard mini project. Now here is what actually, those are the class and the functions. Here is what actual thing happened. We create an object of the leaderboard and add player, all this game, the name and the score. And this leaderboard has vector, and that vector is received or read by get players. All players will be here. Now you sort it. This is a local variable here, local vector. Sort it using the lambda function and using the score. If the score is greater than, that will come on the top in the index on the vector. If it is greater than the score, A's score is greater than B. So AB is coming as a parameter from this array in this for the sort function. And you display all players, it says all players, this is the one. And display all players. And next one is top five, only top five. We got top five, top players, 5. That's the function. We saw that. Then we have score, which is more than 1,000. Get players above this score. So that's above the score, whoever. And by the game. So game is Tetris. So all the player with Tetris game and displays the Tetris leaderboard. And then updated top leaderboard, top players, leaderboard, updated top players. Oh, the value is updated here, so that changes thing. And now the top players might have changed because the 1600 LS is now 1600. Earlier it was 1250. Now Alice is on the top. So top five has changed. And then player with even score, that's another thing. Players, even score, and that's the lambda function used here. And the score mode 2, that means mode 2 is 0, meaning it's an even number. So all the even scores are here, even scores. And name, score, and the game. And then, okay, it also sorted before displaying that. Now, top two players from each game. That's an interesting one. So you have a game and games and get the games, and it's a set. Because it's a set, that has to be unique value. Set cannot have duplicates. So once you enter insert for each game, it will finally, these games will be only contain unique values. So we have those games. And for each game now, each game, we are comparing get players by game. We have that function. So get players by game, and we only want top two. Resize and keep only the top two. So the size is greater than 2, then resize to 2, so that only keeping the top two. And top two is displayed here game. So top two of Pac-Man, top two of Space Invaders, and top two of Tetris. And that's about this project leaderboard. And pretty interesting. And this is using advanced concept of lambda function, the comparator, functor, and function, and the display of the mini project leaderboard. And we covered pretty good advanced concept about C++ STL, and there are more, much more than we cover. The self-study is recommended. And with that, I will see you in the next lesson. And we are only going deeper into the advanced concepts. So thank you so much. I will see you in the next lesson.